Welcome to this video tutorial on application problems involving quadratic functions. Specifically, we have a pool problem up on the board. So take a minute, maybe you want to hit pause, and see if you can solve this before we discuss it. What we're going to do is we are going to draw the scenario out in picture form, and I'm not going to draw the picture to be biased towards how this problem works. We've got a 15-foot by 24-foot pool. So in the middle here, this is our pool. There's the water. And we're building a walkway around the remainder of the pool. Now, there's going to be a different width for the walk here that I'm putting in orange as compared to here that I'm putting in green. One of those we're going to call X. The other one we'll call something else. Now, when we read the problem, it says the walk adjacent to the 24-foot side of the pool is 3 times as wide as the walk adjacent to the 15-foot side of the pool. So as we near the 15-foot side of the pool, we are going to put an X by that piece. The walk adjacent to the 24-foot side of the pool, which is right there, and we will color coordinate it accordingly. Here's the 24-foot side, here's the 24-foot side. Adjacent to it, or next to it, that's going to be 3x because it's 3 times as wide. So then when we go to write out the dimensions, be careful. So vertically, kind of like a height here, we've got a 15-foot portion in the middle. We've got a 3x here, and we've got a 3x here. So overall, that height would be 15 plus 6x. On the other hand, horizontally speaking, on the bottom, we've got an x on the left, we've got an x on the right, and in between them is a 24-foot long portion. So that will be 24 plus 2x. When we go to make an equation that we will solve, we want the area of the walkway itself, which is just this portion here that I'm scribbling in red, outside of the pool that would be filled with concrete. So when we're doing this, we would take the dimensions of the overall shape, which would be the 15 plus 6x, times the 24 plus 2x, but be careful because we have to subtract off the water. So minus 15 times 24, and we want that equal to the amount of concrete we have. Look up in the problem. We've got 500 square feet of concrete, so we'll set that equal to 500. Now, while that can be solved algebraically, we will solve it on the calculator. So first thing that we are going to do is we're going to go to our y equals, and we're going to set the left-hand side of that equation as y1. Make sure you don't make any typos, and please use the parentheses. 24 plus 2x, and then minus 15 times 24. Then we are going to set the other side as y2. Go to our window. The x is the width of the sidewalk adjacent to the 15-foot side of the pool. It won't be negative, so let's make the x min 0. Perhaps the x max is 10. 10 feet seems pretty wide. The y value that we need to see on the graph is 500. Look at where I'm circling in our equation. We need to see the y value of 500. I'm going to go from 0 to 800. Maybe you want to go from 400 to 600. Just put something in where 500 is between the min and the max, and then we'll look at the graph to see if it looks decent. That works. We want the intersection point, so we go second trace in order to calculate. Option 5 for the intersect. We hit enter, We'll guess. I'm going to guess 2. But then it'll zap to where that point is. So now as we go to finish up this problem, we look at the answer that we have from the calculator, and it said x is equal to 2.46. Remember I said at least 2 decimal places, rounded correctly. But that's not what we want. Notice what the problem says. The problem says determine the width of the walkway adjacent to the 24-foot side of the pool. Way to do that is to go home on the calculator, hit your X, realize that, oh, it still saves that in there. And what we want, adjacent to the 24-foot side of the pool, we want 3x. So please use the full decimal, hit enter on that, and as we see, the answer here is going to be 7.37 feet. Please label it, please identify it as your final answer, highlight it, circle it, do something, and that's how this problem works out. Draw a picture, analyze it carefully, form the equation, and then solve.